I'm Austin Guys, and I'm a member of the Flaming Fives in Section I, and I'll be talking about our mechanism to save Buzz. In order to save Buzz, we originally had the idea to slap him. The idea was to take a mousetrap and have it hit him backwards towards the starting zone, similarly to hitting a golf ball. The mousetrap was attached to the bottom of the robot, and a string would be run from the triggering mechanism of the trap to the pneumatic actuator for the car mechanism. However, this mechanism proved ineffective as the bar meant to hit and save Buzz would become stuck on top of him. Ironically, he got in the way of his own rescue. The few times he did not prevent his own rescue, he would hit the axle on his way back to safety. To rectify this issue, a wooden block was added to the front of the robot. This block acted as a plow and would push Buzz to safety. This would, however, sacrifice one of the aliens in the process. However, we felt this was justified because more points could be obtained by rescuing Buzz and sacrificing an alien than not saving him at all and not disturbing the aliens. This plow may have been crude, but it was very effective.
The rocket, the initial plan was a scissor lift base. This would act similar to a skyjack from construction sites, with the only difference being the actual lifting mechanism. Real-world scissor lifts use an oil pneumatic to close legs. Our design used a bolt on the bottom with one side attached to one leg and the other attached to the robot. Once it was spun, the bottom of the legs would close together and raise the lift in a similar way. This design sort of worked, but the motor turned far too slow to fully lift the robot, and the screw was ripped out of the legs during testing. A completely new design was needed, so we went to our backup of a cascading drawer slides. A set of pulleys were attached to the sides of the slides, and a single string was run across them, with one end attached to the pulley on a motor. Once the motor was turned on, the lift was raised without issue. Just like in the movie, the rocket is to infinity and beyond. For the car delivery, a box with all three cars to sit side by side was used. This box would be attached to a pneumatic cylinder which would rotate the box onto an incline, allowing the cars to slide into the designated slot. A long arm switch was attached to the front of the robot to determine when the cars would be released based on the color of the starting zone we began in.
To make the robot move forward, we designed a two-step gear system. A motor turned a top gear, which spun on an axle, and spun a second gear connected to the same axle. This second gear then connected to a gear on the main axle, which spun with the wheels. This system worked extremely well and faced very few setbacks after being laser cut and assembled. Our intended design to place the ball in the center compartment consisted of an arm connected to a large gear, which was rotated by a pinion gear connected to a motor. This design would have the motor turn 4 times in order to turn the arm 120 degrees to the desired ball drop location, where a pin would then be pulled, dropping the ball into the center. This ball drop assembly could be made from all laser cut parts, making the fabrication approach very simple. We believe that our design would be extremely effective and reliable, and that our design would perform very well in the final competition.